So this is from Further Maths Winter 2003, question paper 1, and this was question 2. Given that un is equal to this thing here minus this thing here, find Sn, which is equal to the sum from n plus 1 to 2n of un in terms of big N. Now, luckily for us, we studied our method of differences very carefully, and we can observe that 1 divided by n plus 1 squared minus n plus 1 plus 1 is equal to 1 divided by n squared plus 2n minus n, so that's plus n, and then plus 1 minus 1, so we don't have to worry about that, and then just plus 1 at the end, which is that one there. So actually, if we consider the function f of n is equal to 1 divided by n squared minus n plus 1, then this one here is f of n plus 1. Okay, and so we know that the sum from n equals n plus 1 to 2n of un, we start at n plus 1, so it's going to be f of n plus 1, and then minus where we finished plus 1, so minus f of 2n plus 1. And so that is going to be equal to 1 divided by n plus 1 squared minus n plus 1 plus 1, which I mean, we already figured out that it's this thing here, so I wasted a little bit of time there writing that out, but that's okay. Minus 1 divided by 2n plus 1 squared minus 2n plus 1, and then plus 1. Okay, and so this is 1 divided by n squared plus n plus 1 minus 1 divided by 4n squared plus 2n, and then plus 1. And I'm not sure if it's supposed to cancel down into something nice or not. Let's combine it into a single fraction at least. So minus n squared minus n minus 1, the whole thing divided by the 2 at the bottom multiplied together. Okay, and then we just get 3n squared plus n divided by that huge fraction at the bottom there. Sorry, that huge denominator of the fraction. Now, for the second part of this question, it's not immediately obvious what to do. We're looking for some number m such that Sn is less than 10 to the negative 20 for all n bigger than m. Remember, this thing here is our Sn. And well, basically we're looking for an inequality here. And we can see that, so Sn is equal to 3n squared plus n divided by, and then on the bottom we got 4n to the power of 4 plus 6n cubed plus a bunch of random other terms, and we can see that this is going to be less than 3n squared plus n, just divided by 4n to the 4, since we're dividing by a smaller number here. And then, well, this is going to be less than 3n squared plus n squared divided by 4n to the 4, just to make it a single fraction. And this last one is just equal to 1 divided by n squared. So we know that, in fact, for all values of n, Sn is less than 1 divided by n squared. And so if we can find all the values of n for which this is less than 10 to the negative 20, or 1 divided by 10 to the positive 20, then we are done. But clearly that is true if n squared is greater than 10 to the positive 20, if and only if n is bigger than 10 to the power of 10. So m equals 10 to the power of 10, and we're done.